Hi class, this video is about composite functions and inverse functions. So let's get started. Okay, say we have f of x is equal to 2x plus 3, and the function g of x is equal to, say, 3x minus 7. Then I could ask, well, what's g of f of x, which is sometimes written of g of f of x. And that's really like we can ask for g of f of 2. Well, g of f of 2, right? I first put 2 into f. So 2 plus 2 is 4 plus 3 is 7. So that's the same as asking for g of 7. And if we put in 7 for here, we get 21 minus 7, we get 14. Well, g of f of x is really just a function. I'm plugging in a value for x, and I get out a value for y, or an output value. So it's really just a function. So what is that function? So it's really, well, g of x, or a box, right? What is g? Well, we take just 3 times that box and subtract 7. Whatever I put in for g, right, g of x, I multiply by 3 and subtract 7. Well, I'm putting f of x in there. So it's g of f of x. And that's just going to be, I'm going to say multiply 3 times f of x minus 7, right? That's what I'm going to do. And so that's 3 times, right? F of x is just 2x plus 3, right? Minus 7. And so that's equal to, I distribute, that's 6x plus 9 minus 7. And I can simplify that to simply 6x plus 2. And did it work? If I plug in 2 here, I get 2 times 2, 2 times 6 is 12, plus 2 is 14. That's exactly what I get. So I get this new function, g of f of x is just simply equal to 2x plus 6x plus 2. All right, let's take two other functions. Let's say h of x is equal to x squared plus 3. And g of x is equal to, say, 2x plus 1. Then I can say, okay, what is h of g of 2, right? Well, you plug in 2 here. 2 times 2 is 4, plus 1 is 5. That'll be h of 5, which is 5 squared plus 3, and that's 28. All right, but I can also ask, what's h of g of x for any arbitrary value x? Well, again, that's going to be whatever I put in here, I put here. So that's going to be g of x squared plus 3. So that will be 2x plus 1 quantity squared plus 3. If I multiply that out, that's 2x plus 1 squared, so that's times the 2x plus 1 plus 3. And that's equal to, well, that's going to be 4x squared plus 2x plus another 2x, so it's plus 4x. And then plus 1, if I add that to the plus 3, I get plus 4. So h of g of x is equal to that, and sometimes it's written h of g of x. Quickly, I could easily get g of h of x, and that will be equal to, well, I just put h of x in for that, so into there. So I get 2 times x squared plus 3 plus 1. Distribute the 2. That's 2x squared plus 6 plus 1, so plus 7. And there's my composite function. Now there's a special composite function. Say f of x is equal to 2x plus 3, and g of x is equal to x minus 3 over 2. Then what is f of g of x? Well, that will just be f of, well, I get 2 times x minus 3 over 2 plus 3. 2's cancel, so that's equal to x minus 3 plus 3, which is just equal to x. Now that's a special function. It's called the inverse function. Inverse function. And it basically undoes the original function. Say we have the point x, and f brings it to some point here. I can call it y. I can say that's y is equal to f of x. Well, the inverse function, it's often denoted as f to the minus 1, kind of like a 1 over f, but you know, it's really the inverse function. And that brings it back. So f inverse of that point y is equal to x. And so we have f inverse, y is equal to f of x, f inverse of f of x. F brings it to some value, the inverse brings it right back to x. And that's how we can tell if it's an inverse function. If it brings it back to x, it's an inverse function, and that's what an inverse function is. It undoes it. And for example here, I take a value, I multiply by 2 and then add 3. How do I undo that? Well, I subtract 3 first and then divide by 2. Okay. F of 5 is going to be equal to 10 plus 3, which is 13. G of x, which is f inverse of x, right? F inverse of x and inverse of 3. What do we do? Well, the last thing we did was add 3, so we subtract 3. We get 10. And the first thing we did was we multiply by 2, so undo that, you divide by 2. And that's what we're doing here. And that brings us right back to 5. That's what an inverse function is. Now say I have an inverse function f of x, a function f of x is equal to 4x, minus 5, say. Okay, how do I find the inverse? Well, I basically say, okay, f brings x to y, so I'll let y be equal to, I want to bring it back to x, so just solve for x here. I add 5 to both sides, y plus 5 is equal to 4x. Now I divide by 4, I get x is equal to y plus 5 over 4, and that's my inverse function. If I want to write it in terms of f of x, my f inverse of x, I just replace y with x, just a dummy variable, but that's the inverse. And does it work? Well, f of f inverse of x, that also is equal to x if it's true inverses. Let's see what we get. Let's put this guy into f. We have 4 times x plus 5 over 4 minus 5. The 4's here cancel, and you can already see it. X plus 5 minus 5 is equal to x. And so this is, in fact, the inverse of f of x. It undoes it. Let's do one more example. Okay, and let's just say something like f of x now is equal to x squared minus 3. How do we get the inverse? We let y be equal to x squared minus 3. Solve for y. Y plus 3 is equal to x squared. Now we take the square root. Square root of is equal to x. And so we have f inverse. I actually like to use y's, but they're dummy variables. Right, we'll take y back to x. Is equal to square root of y plus 3. Now does it work? F inverse of f of x should go right back to x. Well, does it work? Well, I'm going to take this whole thing in the composite thing and put that in for this dummy variable. So that will be the square root of x squared minus 3 plus 3. And you can see it. That's the square root of x squared. And that's equal to x. Okay, one last example. Say f of x is equal to the cubed root of x plus 2. All right, so again, we let y be equal to the cubed root of x plus 2. Now we cube both sides to get rid of that cubed root. Y cubed is equal to x plus 2. And we get x is equal to y cubed minus 2. So f inverse of y is equal to y cubed minus 2. And if you prefer x's, f inverse of x, it's just a placeholder dummy variable. You put it in, whatever you put in there, you put in there. Okay, well, I hope you enjoyed this video on composite functions and inverse functions. Hope it was useful for your learning and you enjoyed it. Cheers.